Hi everyone, thanks for watching my video. In this challenge, basically for KNIME, I'm really impressed with the software. I mean, the overall workflow and the function flow and how you can build an end-to-end prediction project. So that was really fascinating. So how you can perform various data processing steps. You can do the visualization, build the prediction model, test it. So it was really nice. So for this challenge, I chose a dataset that I already had. It was a dummy dataset, basically used in one of my other projects, where I used it for some coding to test my coding, and I thought it will be a good dataset for testing the various features of KNIME. So for this, what I did was I had two files basically. One was patient file and one was event file. So in the patient file, I had data about all the patients and their demographic information. And in the event file, I had the various diagnosis details corresponding to each patient and at what time it happened. So these two files I chose for my analysis, and my goal was to basically build a prediction model which can predict based on all these parameters what could be the possible outcome or what could be the possible diagnosis, whether a person will get a heart counterstroke or maybe admitted to hospital or vaccination. So these kind of things I wanted to predict using all these variables. So I started with loading the data. So I loaded the patient file using the file reader. Similarly, I loaded the event file. So an event file was really huge. So I had initial challenges where the software was not able to process this huge file and had difficulties in building models. So for that, I had to partition this data and just take the first 5,000 events or the diagnosis as part of my analysis. So if you see here in the configuration step at the file reader, I have partitioned it to first 5,000 rows, and then once I had both the file reader and the event data, sorry, I had both the patient data and the event data in the file reader. I connected both of them and I wanted to join them into a single data set based on the patient ID. So I used a joiner where I joined them using the patient ID, PID column, and it gave me a joined table. So this table has data from both the files, and now once I had the joined data, I wanted to remove the unwanted columns so that I have only the columns which are meaningful or which could be used for my prediction. So I removed all these unwanted columns, and I was left with only the main columns. So this is my column filtered data, and so in the modeling step, after I had uh, did the initial data processing and I had data in the correct format, I wanted to partition the data so that a portion of the data is used for my training and to build the model, and the remaining data is used for performing prediction. So for that, I had a node called partition. So in the partition, basically, I partition data using stratified sampling. So basically, in stratified sampling, you divide your whole population into different data sets, or you can say different groups based on your particular category. So in this case, I have chosen ethnicity. So based on ethnicity, I have divided my whole data set into different groups called strata. And out of that, now I'm choosing 30% as my first partition, which will be my training set, and the remaining 70% will be used for the prediction. So I have just taken this image from Wikipedia. So if you can see, like, this is your whole population, which is divided into four different groups. So in my case, it will be, say, four different types of four different ethnicity group, and from each group I'm taking 30% you can say, as my sample, so that I have a good sample for building my population from all different types of category. So one actually issue I felt was there could have been more different ways of getting the data, partitioning the data. So it had only like based on one column, you can just pick a percentage of data. So maybe they could have used something more. But anyway, so I've used this, and so this is my first partition, which is around 1500 transaction, and the second partition, which will be used for prediction, which is around 3500 transaction. So yeah, so that's it. And so this is my complete workflow. And so here you see I have decision tree. So my first partition is going to the decision tree learner, where it is building the model and learning it through the data. And the second partition, and that model is then is actually sent to the predictor with the partition data, second partition, where it actually builds the partition. And I have also added a scorer in the end. This helps you to get all these statistics to evaluate your model, know how precisely or how accurate your model is and how good it is in predicting the values. So as you see here, this is the predicted table, and there's a column in the end which is added as a prediction. So it contains all the predicted diagnoses. So there are many which are off, and there are many which are matching. So based on all the first column, the description, that is the second last column, is the observed value, and the prediction is actually what is predicted by the model. Uh, So the scorer is basically gives us the confusion matrix, and it tells me that the accuracy is very low, that is 60%, and the error is 39%, 39.9%, and it tells me like where exactly it went wrong. So so to check that, basically I used another table provided by the scorer, which was accuracy statistics, and it gives a much broader information at each at different values of prediction, such as if you see on the first column I have all the predicted values. So it tells me at different predicted value what was the true positive, false positive, true negative, false negative, what was the precision, what was the recall. So if you see in the first row, so it predicted everything accurately, and it had like 100% precision, 100% recall, 100% for F measure, specificity and sensitivity. But if you come and down and see around um, fourth row, so I think something went wrong there, and it was like only 22%. So probably I'll have to refine my model and see what is the issue, and come up with a better model which can predict it more accurately, maybe just removing some extra columns, something like that. And maybe due to noise, these it is showing me all these extra it is predicting wrong values. So maybe I'll have to remove the noise and bring some more clarity to it. So I also tried few visualizations, such as I added a color manager and added a pie charts to see how my data is distributed. So it gave me this pie chart where males are around 61%, and female count is around 38.56% of my data set. Similarly, on a few pie chart on admission source and admission type. So my future work will be to further refine this model and do it iteratively to reach to a model which can give me a better prediction and with a higher accuracy. So so for this analysis, for this challenge, I think it was really great in uh, basically understanding these different features. Maybe in future I'll try to build a much better model, or maybe use it in our overall project to see what other uh, benefits I can have from this particular software. Thanks for watching me. This was all for this challenge. Have a good day. Bye.